In this video, we're going to develop a model of exchange rates, one that's focused on being able to look at how monetary policy might affect exchange rates. So first off, one of the building blocks that we need is this concept of what we call the law of one price. And what this says is that if you have a tradable good and you don't have any barriers to trade, right, and in fact what we call frictionless trade, right, you don't have high transaction costs, then that good should have the same real price, right, or the same effective price in the two different countries. So what does that mean? So imagine that we take the U.S., say, as our home country. Well, we have the price of some good here in the U.S., and the superscript G is just telling us it's the price of a particular good. And I should be able to buy that same good, let's say it's a shirt, for the same price in Italy. And if it's going to be the same product, right? It's the same shirt in Italy, should go for the same price once I've converted the euro price into dollars. So in other words, and how do I do that? Of course, I take that price, right, of the good in Europe, in this case I'm saying Italy, right, note that's right, so that price is going to be denominated in euros, right? So I'm going to take however many euros, let's say it was a 50 euro shirt, right, and I have to multiply that by the dollar to euro exchange rate to convert those euros into dollars, right? The law of one price says that those two prices then have to be equal. Right? So if we take this concept and we say if this holds for every single good, then in aggregate, that is going to hold for the price levels in the two different economies. Okay? And we call that concept purchasing power parity. Right, so really it's the same equation, but instead of saying it's the price of individual goods, we're saying this holds true for the price levels. Okay. Now we can take that equation and we can rearrange that and write it the following way. And so we can isolate E. So in other words, we're going to bring the price level in Europe over. I'm going to write it in terms of the exchange rate, right? That the exchange rate, and according, again, this is, again, starting from this building block of law of one price, and then aggregating up to the price levels as a whole in these two economies, we get that the exchange rate is equal to the ratio of the price levels. Okay. And why is that important? Well, now if we're talking about trying to understand how exchange rates are determined and how they might change, you can recognize then that what this equation becomes if we look at rates of change, and is that the change or the percentage change in the exchange rate right, and that's what this term here on the left-hand side is the percentage change in the dollar-euro exchange rate is equal to the percentage change in the price level in the U.S., which is simply the rate of inflation in the U.S., minus the rate of inflation in the Eurozone. Right? And if this was the dollar-yen exchange rate, it would be the difference in the inflation rates between the U.S. and Japan. Right? So this gives us a very nice way of thinking about this concept of purchasing power parity. Right? What we're looking at here is the first term is, we would call this absolute purchasing power parity. And the second one is relative purchasing power parity. And one of the things we're going to discuss in class is that absolute purchasing power parity doesn't seem to hold terribly well in the data, but relative PPP does. And that's one of the reasons why we like to work with the concept of relative PPP, because in practice, it seems to hold fairly well in the long run. And we're going to make a distinction between short run and long run movements of the exchange rate. In the long run, relative PPP seems to hold fairly well. So now the question becomes, well, what determines the rate of inflation? And so we use what we call the money demand model, or the money model, here to try to answer that question. And so we think about people's demand for holding on to money, right? And we equate that to the supply of money in the society, and we say that that is what ultimately determines the price level in an economy. Right? So money demand is a function of this, what we call this L bar, which is this kind of money demand constant. Right? And that's going to be determined by a whole host of factors. You think about things like demographics, how big are households? Do you have an average young population that wants to spend a lot because they're raising kids, sending them to college? It's going to depend on other, say, intrinsic factors about the population as well. But for any given point in time and for any given country, we'll take that as we'll take that just as a given and as fixed. Right? So it's our constant, right, on the demand side for money. So we have that constant, and then we multiply that by P, which is the price level, times real income. Right? So Y is real income. And of course, P is our price level, and as we just said, L is our constant here. Okay. So how do we think of P times Y? Well, right, since we're multiplying real income times the price level, P times Y is nominal income. Right? Remember, what is the difference? You got to keep in mind the difference between real and nominal income. Right, is that nominal income is, if you think about it, is just the amount of money that you have, whereas real income is the purchasing power of that money. Right? So we have that same distinction here. So we can take this equation here, and if we could always rearrange it and say that, well, real money demand, so that's money demand divided by the price level, is equal to this constant times real income. And so what does that then do for us? Well, we're going to take real money demand and set that equal to, you could think about, you can imagine setting money demand equal to money supply, right? So if we were to actually take money demand and say, and that's what money demand is, set that equal to money supply. The other way we think about this, right? So, and this is, right, so say we have money supply in the US would be equal to this L bar for whatever that value that takes for the US times the price level in the US times aggregate output in the US. Okay? And then we can take that equation and rearrange it and just isolate P. Okay? So the price level in the US, and you can see, right, why this is important. We're isolating the price level because we're saying the exchange rate is equal to, right, the ratio of the price levels. So the price level in the US is equal to the level of money supply in the US divided by our constant times aggregate output. And of course, the same equation will hold true in the Eurozone. So we have the same equation here. And now we can just take these two equations for the price level and put them into our absolute PPP equation. And that will give us at the exchange rate, right, the dollar-euro exchange rate, we plug this equation here. I'll call this, but label these, it's easier to keep track of, equations 1, 2, and 3. So I will plug 2 in the numerator here in 1, and I'll also plug 3 into the denominator here in equation 1, and that will give me money supply in the US over that constant times aggregate output all over the same fraction here, the same term, but for the Eurozone. So now we have all that put together, we want to think about how we can break this out. Well, so in growth terms, if we think about this, we've got kind of 4 things actually going on. Right, we said L is a constant, right? So the growth rate of L is 0. Okay? L has no growth rate. So if we look at the growth, right, or the change of the exchange rate, the percentage change in the exchange rate, which we can also term as the growth rate of the exchange rate over time, that's going to be equal to the growth rate of the money supply, which we'll label as mu, growth rate of the money supply in the US, minus, right, because it's in the denominator, the growth rate of output, which we'll label with G in the US. And then because it's in the denominator, we have equivalently the growth rate of the money supply in the Eurozone minus the growth rate of output in the Eurozone. Okay. So the percentage appreciation or depreciation of the dollar with respect to the euro is determined by these 4 growth rates. Right? The growth rate of the money supply in the US minus the growth rate of actual, again, real income, right? This is real, think about real GDP growth, minus the difference between the growth rate of the money supply and real GDP growth in Europe, right? So one way to think about this, let me just say, well, if the money supply is growing at the same rate as GDP is in Europe, so let's say that the money supply in the Eurozone has the same rate of growth as GDP in the Eurozone. Let's say they're both growing at 2%, okay? While on the other hand, money supply in the US is growing at 4% and the economy in real terms is growing at 3%. Then what's going to happen? Well, then this equation simply becomes 4 minus 3% minus 2% minus 2%. So that second term goes to 0. And we would see that the dollar to euro exchange rate would rise by 1% per year. And again, it's important to keep in mind when we're saying that the dollar to euro exchange rate is going up, right, that's saying you need more and more dollars over time to buy 1 euro. We're saying that the dollar is depreciating. Okay? And so this is how we can look at this, because if we take economic growth as, say, a given, not affected directly by monetary policy, at least in the long run, then really monetary policy is just affecting, right, the growth rate of the money supply, right? It's a one type of monetary policy. So that if we have an increase in the growth rate of the money supply, ceteris paribus, right? Increase the money supply in the growth rate in the US, holding everything else constant, that will cause the dollar to depreciate relative to the euro. And so one of the things we want to do in class is to see, well, just how well does this equation hold up to the real world and to data from different bilateral exchange rates.